All right, we're here. Let me. What do I got to do? I got to hit this button right here. Oh, there we are. Okay, did training all morning, and rushed back home to do this. Ate a very quick lunch. I think I'm gonna be okay. Got a little Coke. Good. Okay, you know the drill, Kevin. We got to kind of remember where we.
Exactly.
I remember being excited though.
Yes.
that I remember. So let's see. Let's switch over to our screen here. Try to remember. I also remember that we left ourselves some notes somewhere. Probably right in there.
There it is.
Yay, we have handshake working. That was pretty cool. Oh, that's right. We did that whole handshake test, didn't we?
Yep, with the diagram in Excalibur.
Oh, I found out that JetBrains supports this Excalibur plugin now in the training, so that's kind of cool. Let me see. Sometimes I gotta go smaller to see it. Oh, oops. All right. Oops. Boy, I look like I'm drugs today. All right. So we got that working, right?
Yep, we got handshake.
We did that with a little hack tool, our little client hack, right? Okay. So our client hack did the handshake now. So where is it? So it connected to a socket. We said hello. It sent us JSON. We said welcome. I want to see that run again anyway. But we have handshake working. We want to test handshake errors, including server timeouts. Oh yeah, all that stuff is nasty. Router package. Oh, we need the router package to start sort of doing this. We have an ID now. Then we can finish this code that I sort of commented out. But why don't we come back in here. Where am I? Yes. Yeah. All right. Let me also go in there. Code. I think, oh, I put the whole project there. All right. Ardan Labs. Okay. So we could try this again here. So we have a make run, right, in the make file. Max is complaining because I didn't give him any lunch, dude. And now he's going to do this. I have to put him to bed here. This is him crying because he smells lunch.
Food and he's not
he smells
any.
food, and I always feed him. And we've been in a rush here. So we had that, and then we had the hack, right?
Mm-hmm. Yep.
And he doesn't want to eat his Kittle because he knows there's like good food out there. This dog's amazing.
He wants the good stuff.
No, of course. And then eventually he'll cry, and then he'll give up on the good stuff and eat his kibble. But he's going to moan for the next 20 minutes. You watch. Actually, I should just give him a regular snack because I got home. So I'm going to go do that on live television right here. But there's the welcome Bill Kennedy. So I think I saw a bug on this output, this logging. You see the started handshake read and completed handshake read?
Yep, and there's no, it's just
I remember
zero
seeing
value.
that after we, I want to see where that is because that shouldn't be zero, man.
We did something with new trace or...
I don't know where that, here, handshake, that's what we're seeing, right? Handshake, completed handshake read. Completed, that just takes handshake completed. Oh no, this one right here.
Completed handshake read.
I don't know where the word read's coming from. Okay, so sometimes when this happens to me, and I have no idea where, oh, well, Chap app 130. Here it is right there. Somehow this context, when we call it, doesn't have the UUID in it. So the question is, where are we calling read message from? Sometimes what I'll do is I'll just do that, and I'll see where it's being used. Ah, that is the mistake right here. See the background context here on handshake?
Yep.
That's not good, right? We should tell it to take a context.
Yep.
Like that. And then, we could do this if we wanted and then pass that in. So let's put read back. We could still decide we're only going to wait 100 milliseconds based on that, but that handshake should take a context. So now, if we do this again, we should have, this is because we were hacking a little bit.
Yep.
But I noticed this right when we had sort of finished yesterday, and it was like, oh no, I know we have a bug there. We just got to fix it. All right, now everything's under the right
No,
ID, thank God. So we've got that there. Okay, so we'll get back to the important stuff here again. I was worried about test handshake errors, including server timeouts and things, router package map users. So I'm going to do this, all right? Because I don't know, things change sometimes day to day. I would love to just get the happy path working here.
Okay.
Think about negative path, and then test some negative path stuff. But if we can get happy path working, I don't know, feels sort of better, right?
Yeah.
So we decided that once you did the handshake, then you were in the system, and then somebody could send you sort of a message back. That was the idea. And so we've got the handshake working, and then the idea is you would get into the ability to wait for somebody to send you a message, or you could send somebody a message. So I don't know exactly what this looks like just yet, but I do have a big message saying we need a router package. So once we finish the handshake, we know two things about you. We know your unique ID,
Yep.
and we know your name. We don't have to care about how people get unique IDs or anything like that. We have that. Now, I was just thinking, this thought just popped into my head. I mean, as part of the handshake, oh no, you would need somebody's, yeah. I was thinking we could generate the unique ID, but that's not going to work because our people can't just do it by name. That's the problem. You just can't do it by name, right? So let's solve the idea of how somebody generates a unique ID for themselves or whatever. It's not going to be terribly important. But we need this sort of router package now. Now, this package is going to have to map this user to, I would say, this WebSocket connection. And more importantly, the UUID than anything else. So the first question I'm asking myself now is, do we want to make this a support package just for the app layer? Or do we want to make this sort of more foundational where it could be used for any other app that needs this? I don't know if we're there yet. I feel like this is still very specific to this project.
I agree.
So we could start off with this being an SDK package, and then we'll go from there. I don't think this package should use the app domain model because that would be a violation. But it doesn't. It just needs the UUID from my perspective. However, you see, here's a problem. We would need the user if we needed the name for anything, which honestly we'd want to send back who did this. So we do need the user model. So the question then becomes, see, now we're having problems with data models. We need to store this user model. So either our package has its own copy of this, which is the cleanest way to go, or this whole handshake code that we wrote down here can be part of this new package. That way, this package owns the data model that can be used to formulate the last sort of response.
Okay.
Right? Because really, this is lower level stuff. This is the important thing, being able to call handshake. But I think if we move handshake and move this model into our package, and that model, then this would have the user model. It still needs its own models for sending things out. But we're not like creating a support package that's now tied to a domain package. That's bad.
Okay.
Really bad. It should be the other way around. So the question is, what do we want to call this router package here? It's more than now routing. It's also helping with the handshake and everything. What we could do, maybe we just call this chat for now. I don't know enough, but I think we could call it chat, and that would be fine. So package chat provides, say, support for chat activity. I don't know. We'll come back to that too. Now, if chat, we're probably going to need a type called chat because it's going to have to do a few things. I know already, based on what we just said, right, that this whole handshake functionality, let me take this for a second. If I were to move it out of there, it's going to go red. That's fine.
Yep.
And chat, again, represents an API, right?
Mm-hmm.
So we'll call this C. This will also help us kind of get a sense of what's changing there. Now, we use this as the WebSocket. I'll just change it like that. I don't mind all this red right now. Sometimes when I do this, it helps me also sort of see the code that I'm changing.
Yep.
So I can better look at sort of what we were doing.
Mm-hmm.
So I don't mind that this is going to take us a little bit longer. We do know, though, we need this model.go. Maybe I'll just copy it and then get rid of this. And this is just going to be chat, and that's fine. So this is going to be tied to the WebSocket package, which is fine. I think we have it here. I'll just pull that import.
Yep.
Sometimes when you copy and paste code, the go please server starts to get lost here. And this is going to have to be an exported there. And I don't even know if it needs to be a method, right? I mean, from my perspective right now, it may not necessarily need to be a method since you might not need anything there.
Mm.
Now, this wanted to call read message. Let's see what happens if we do that. I don't know what it was using other than the logging right now. So let's just see where this goes. So handshake did this, it did read message, formed a user. This model now has to be exported. User represents a user in the chat system. Great. This will now return a user. Beautiful. This also has to return. Again, I could have used some tooling for this. It's not important to me right now. I just want to see what's sort of red and what isn't. So far, this tells me that this definitely could have just been a function. We didn't need anything from a receiver perspective. Now, when I come to this, and I made this a function, we had a go routine in here.
Yep.
That we wanted to see some logging with, right? So we had a couple questions now that we can sort of answer here. This is in the app layer. This is an app layer package. If it was a foundation layer package, we wouldn't be able to use our logger. We'd have to create another sort of mechanic for that. But we are in the app layer, and so importing the logger here is absolutely fine. I mean, it's app layer code.
Got it.
The question that we want to ask ourselves is, do we want to make this now a method where, if I come back to chat app for a second, all right, we could say, okay, now we need a logger. So there will be some sort of new here, all right. Copilot's doing a pretty good job. I'll let it continue. Where we'll do that, right? Chat, represents a, our chat. Not really a chat client, right? Sort of chat support. I don't know. We'll come back to that. A new, it creates a new chat support. Fine. So we have that. Now, if this is going to be the case with the logger, now we can go back and make this a method. But what's funny here is, in this particular case, we're not really using the variable, right? We could just say chat there. We're not using it. It's a good indication that we've made it a method. But the reason we need it to be, actually, we're going to need it, aren't we? Because I'm going to do a C dot here. But we could keep that unexported. That doesn't need to be exported at all. And now that gives us access to the logger here. So
okay.
that kind of sort of solves a few of those problems. And then the read message, that's fine. It's doing all that. Now, on this log at this point, what I would say is we send a message called chat, and then we could say like a status. And we can do sort of like that, right? Yeah.
Yep.
just because now we know it's coming from, say, the chat. Again, it's an app layer package, so none of that is a real problem. All right, so none of that is a problem. None of that is a problem. But now this is all under a chat thing. So now what we know is we're going to have a chat, which is a pointer of a chat, okay? And then technically, we could create that chat, new chat, because we already have a log.
Mm-hmm.
And that's kind of nice. So the question is, do we want to construct that in main and bring it through? We have everything we need, so I don't think this is a big deal. And now this just becomes chat.handshake. And now we're sort of clean there. And we have the beginnings of being able to manage the different connections and everything that's going on. So you see how that sort of worked out. Everything looked red and ugly, and everything is now back to green and stuff. And we could try and run that. I don't think anything is going to break, but we could try it just to be sure. So we'll run our chat thing again, and we'll do make chat. Welcome, Bill Kennedy. Yay, yay, yay. Well, that worked, so that's good. Okay, so that kind of cleans it up, because I didn't like that code in here, because I felt like it really wasn't a handler.
Mm-hmm.
And I started to get queasy when we're putting non-handlers in there. But again,
Okay.
we didn't know enough. But now we found a much better home for this sort of lower level stuff. Okay, so we know that we're going to need to be tracking. Okay, we're going to be tracking, say, users that are connected. And it's going to be more of this connected to a WebSocket. Okay? Like, that's going to be our map. And if we're going to have a map that's going to be running in any sort of concurrency, we're going to need a read-write mutex.
Yep.
Because we're going to have to read it, but we don't want to block every time we're reading. We probably have more reads than we have writes. We're only going to have a write when there's a new connection. We're going to have
Okay.
reads as messages are coming in and out. So we'll have that. Now, instead of keeping this thing in the raw, there's some basic activities that we'll need to do against this map, right? So think about it, right? Func c start chat. We'll have some sort of add user, right? I don't mind that. And Copilot's been pretty smart here. We're going to definitely need a full lock
And unlock.
and unlock.
Yep.
And we're going to have to do that. What is our user again? ID and a name, right? Now, we could change this to be a little bit, instead of making this a user, we could do that
Okay.
and do that. And now the key is only a 16-byte sort of thing as opposed to this big sort of struct. I think it'll be a little bit more efficient, right?
Makes sense.
Yeah. And the add user, well, now here's the question with add. Here's a question. Add user as used to chat. Now, do we care if that ID is already there? Should that return an error saying this ID already exists? Or do we just say, you know what, maybe something dropped, the new ID comes in, so we'll just replace the connection and it will be sort of clean? Because if we do establish connections already there, it's a good chance that it dropped and we didn't know about it and we didn't delete it, and then there's sort of no reason to delete it. So
Yeah.
at this point, let's just replace it even if it exists. I don't think we need to know. Now, not knowing could also mean that there's bugs that we're not aware of as
We're not
well.
there
Like
yet.
I've been in trouble sort of both ways here. But if the user was there and it came in, then we would have to delete and add it anyway. We're just sort of spending time. The only reason I would say do that is so we could write to the logs, because to me that would be unexpected. Now, what if this person's trying to establish 2 chat sessions like we do on our phone? I have the phone and I've got the laptop,
Okay.
right? So in that case, we have just replaced their connection from one to the other. So thinking about that, should this be a slice of connections? And that would allow them to sort of log in across multiple devices, let's say at the same time,
And
right?
still be able to chat. And
Yeah. Now, the problem with this, though, right, con as a struct, there's nothing sort of exporting about it. There's no real way to know. I mean, there's a local address. I don't know what that sort of returns. Returns a net address. And so there's a network, which is a string. We'd have to look at that because we wouldn't want to have two sockets, two exact sockets at the same thing, right? So all this could be happening. So I don't want to get ahead of ourselves, but you can start to see kind of what would happen there if that's the case. So if we want to return an error, then the idea is that we wouldn't accept the socket connection and we would say, hey, you're already connected. You know, drop the other connection. I'm going to do that because I feel like having this information in the logs helps to also start to see if it's expected behavior or not. And then later on, we could sort of do that. So what we want to do then is first check to see, right, if exists, this exists, return. Now, we could just return that error, and that would assume at that point that if that's the only error that we're ever going to return, then the caller can feel confident that it's failed because the user already exists. Now, it may not be a bad thing. We're going to move this up at the top. ERR user exists, right? To do something like this. And even though this is the only error that's going to exist, I like to put my error variables up here. What it kind of does with this API is it gives the caller a more warm and fuzzy feeling that if it gets this particular error, even though it's the only error it's going to get right now, but that might change over time, that's why it failed. And anything else would be, let's say, just sort of lower level. We don't know. Maybe eventually add user also needs to make a database call or something. So,
Gotcha, okay.
So by having the error variable, that's something we can check on the other side. Now, sometimes you might read the code and go, oh, this is the only error, so I don't have to do that. But if things change over time, you're not prepared for it. So adding a user assumes that the user does not exist, right? So adds a user to the chat. If the user exists, it returns an error, right? So now we're telling the person of the API what's going to happen if the user already exists. So because of that, if there's an add user, we're going to essentially need a remove user. I like Copilot sort of helping out a little bit, right? It's reading my mind.
Someone suggested using a combined ID, a user ID with a device ID.
We could, right? We haven't solved. It's not a bad idea, but we're kind of in the dark a little bit still on how we want to identify clients like that. So Rodrigo's right. When we're ready to go back to figure out how we even generate IDs for somebody, it would be, see, we don't want somebody to have to like configure the device ID. It would be good if you could get device IDs. So you're right about that, but I think it's a little too immature to deal with that right now. But when we're ready to do, say, multi-device, for sure there would have to be a device ID that we would add to the protocol. So I love that idea, but let's just start simple. Let's get this working the way we plan.
We'll build our way up.
And then we can build our way up. But I think Rodrigo's right. We'll have to add the device ID, whatever that ends up being, to be able to do that. So that's good. So remove user. Again, what I would want to do, mainly because this is going to help find bugs,
Yep.
right, is this. But if it doesn't exist, then we can add a error user not exist. Something like that. And use this for the remove, right?
Mm-hmm.
And again, return nil. Again, if you don't do this kind of stuff, it's going to end up biting you because you're not going to see it in the logs. All right. Now, you see how I have my 80 gutter here?
Yep.
Oh, that's right. I really have it because I don't want comments really going past that. I mean, code can occasionally do that. But like even this, right? I see that's that. But I see this, right? That could be harder to read. This might be a case where I move the if down
Separate it.
just to keep everything inside that 80 mark. When I can, I like to do that. So especially like you're going to start looking at this code on GitHub or something, and that 80 gutter is really good at that point if somebody's looking at that.
Okay.
Now, I'm not going to make this go on a second line because that to me is not readable. So that is what that is. But like that to me is fair just to keep it within the 80. So we've got an add. We've got to remove. The most important thing is going to be the find,
Yeah.
right? Now, it called it get. I hate any API that says setting get unless we're dealing with like context. So what do we call it? Find. Now, the question here is, yeah, so given a user, let's return the WebSocket. I think Copilot was kind of smart on this one. And if it doesn't exist, return an error. Now that's right on the edge of the gutter, so I'm just going to leave it. But let's see what Copilot did. So it used a read lock. That was smart.
Okay.
It did a thing. I don't like using OK. I like asking if it exists. That's just something that I do. If it doesn't exist, then the user... Now, is that really an error, though, if it doesn't exist? I mean, a message is going to come in. We're going to want to check if it's there. Yeah, one of the Go idioms is to sort of use errors for these things as well, right? So we know that over time we might not have that user. It's a possibility. So one could argue, well, it's not an error not to find a user. But at the same time, we need to indicate whether or not we found it. So I think that could work. Maybe we end up changing this later. Now, I don't know if I want to return a WebSocket. I think find is going to be a little different. When we add a user, because like, look, when we remove a user, so this gets really interesting to me. I don't know what the right answer is just yet. We created this user model, which has an ID and a name. When we get back, when we start having these messages back and forth, I'm not going to be asking them for their name again. I'm only going to be getting their UID, right? I'm not going to be getting their name. So when it comes to removing, the caller is only going to have the UUID, right? We're not going to have the name. The name is really part of the object that we might send back. So for my purposes here, again, from a protocol perspective, it's going to be more like this. And I would say we would return a user. So here's Copilot making some decisions that maybe some developer would have said, well, Copilot wants me to do this way. But it's not really the right way to, I don't think, to do it. Because we have to think about what we are going to have when we're making these calls. And now, that is a problem. Because we were only storing the WebSocket here. Maybe that's what confused Copilot. That's really probably what we want. store a copy of the user in there. We don't want to use pointer semantics here. We want to use value semantics. We can keep a copy of this, the ID and the name. We don't need to be sharing that.
Yeah.
Oh, but now we've got a problem.
Because
That user doesn't have a WebSocket connection, does it?
No.
Now, the question is, should that be exported? Do we want to give back raw access to the WebSocket? I would say no. In fact, that to me is really ugly. So what I say we do, right, is have a different type, right?
An unexported version.
Now that to me gets interesting because what we could maybe better call this is a con. So we have a con, and then we have the user related to that sort of con, right? Again, I don't know enough about how we're going to use it. We're still making some sort of guesses. And sometimes then it might be better to start in the chat app side to get a general sense of how we're going to use things. But for me, this might be more interesting because then when we add this, we're going to add a con, and we've got the ID, we got the name, and then we sort of start. Now we're having a clashing name here with our type and our variable. So instead of calling this con, let's just start with a connection for now. We might even change that. So I like this too because we're kind of keeping the state we need separate from what we're going to send back. And sometimes that, and you'll see that more and more, the more we sort of do that, the more flexibility we have over time as well. So then what this says to me for a remove, that doesn't really change. But in this particular case, let's say we got back a connection, right? Hitting all the wrong buttons. All right. But then we want to return a user. So a user is going to be a, dude, I cannot type today. This is the cool part about the Copilot, does that for me, right?
Yeah.
That way we're going to move from a connection back to a user, and they'll get a copy of that with the value semantics. We're keeping everything really sort of clean. There's without no pointer semantics, there can't be any sort of side effects.
Got it.
And what we're storing, right? I don't want somebody to get back a user and then they see there's an unexported WebSocket connection. Like, it just feels ugly. Plus, it doesn't feel like data anymore.
Yeah.
You know what I'm saying? From a user perspective. So I like this. This is sort of clean. And then there's this idea of a find this user and that. Now, the find is fine. But I don't think that we're ever going to really use find. I think what's going to happen, all right? And again, this is where maybe we model out chat app first a little bit because we're guessing about what this API needs to be.
Okay.
We're saying add user, remove user. But I think what's going to happen is this.
Okay.
This is what I think is going to happen. All right. I think what we need is a send message, right? Sends a message to the user.
Because really, if we're finding a user, it's to send them a message.
Send them the message. But we're going to want to know where that message came from, too.
Yeah.
Right? A message comes in. So we're going to need probably another model at that point, too. So think about this for a second. We're going to need maybe some sort of message struct. Maybe this is exported. All right. Now, what would a message struct need? We'd need to know from
Yep.
to
Another UUID.
and
message
the
itself.
message string. Right? We would need this. Okay. Message is represent the message.
Sent by
To be sent, say to a user, right? From a user. We agree?
Yep.
And we can imagine that in our protocol, this is sort of what we're going to get back, right? We're going to get this from, to, give this. Eventually, we can even do that, right?
For group
And-
messages.
Yeah, so you can see where this is sort of going, but one thing at a time. Now, what that would mean is we could have gotten that off the wire. So then what that means to me is we've gotten this off the wire, okay?
A lot.
So we want to send that message. Now, it would be nice to also know who sent that message. So though this is the message, right? This is, say, the incoming message. And maybe we'll just shorten this up right now for in message, right? There's gonna have to be
Out.
an out message. So on the receiving side. So the in message is, and maybe this is, so this is a message that we received, right? From, to, and then we have to sort of deliver that message, right? See what I'm saying? So if you're on your chat client and you say, I want to send a message to Bill,
Okay.
you would sort of send, let's just call this in message again for now. So you'd say, from me to Bill, here's the message.
Okay.
Now, I got to receive it. I got to know that this came to you from you, and I'm going to display it. Now, maybe we could use the same just message if we add one more field.
Type.
We're not going to keep it a string. But if we had a type, that would give us some indication on, is it an inbound message to us where we've got to route it?
Okay.
Or is it an outbound sort of message to that person? So maybe we don't need type, because anytime a message is received by the client, they can just assume that it came in, right? Maybe this is overkill. So maybe when we receive a message, we know that somebody wants to send a message from them to this.
Yeah.
When the client receives the message, they know it was
It's
to them
from
from them.
Yeah.
Okay. Now, this probably works. The problem is that the UUID really isn't enough.
Wouldn't we want a name?
I would want that,
Okay.
right?
So then would it be from and then to instead of from ID
Yeah,
and to ID?
I like that. So from to, and we could basically, yeah, you wouldn't even have to touch that message, let's say, if you sent it back over. Now, since we're dealing with these types, and let's say we would do everything in JSON right now,
Copilot helping out.
yeah, this is the cool. These tools are great when you know what you want to do, and then they'll enhance that. But when you don't know what you want to do yet,
It could lead you on
sometimes.
a wrong path.
So that would mean that we need that. We need that. Oops. Sometimes I hit the tab. Right. Like that. Okay. So that's kind of cool. Let me move this up here for a second. So, given a message with a user, we should be able to route that, right? So let's go back to this for a second. So we're expecting you to give us this. A user to, now again, this is where I go back to. Are they going to have the user information? No. All they're going to have is
The name.
IDs.
They're gonna see IDs, or are they gonna?
They're just going to get IDs. They're not going to know names.
Of who sent them the message.
Yeah, at the end of the day, our protocol should only have to be ID based. So, right, so let me just say message here for a second. I don't know what to call this yet. You see, from my perspective right now, okay, from ID, this is what is going to come off the protocol.
Okay.
We shouldn't expect the name to have to be important. The IDs is what's important. All right. So you have your from ID. Your to ID. And then the message again, right? Okay. So that to me is the input for this. And again, we could just call this capital message for now, just to, it's cleaner. So there's a message. The message is all the routing information. But now we have to look up these IDs to get the names and to get all that other stuff, right?
Got it. Yeah.
In order to create to do this. And since these are unexported now, we can get rid of this. And the only exported type so far that I see is this. We'll put the comment down in a second. So let's play this one out. So given a message, we get a read log. Now, we need two things from our map, right? Says connection. We need two things from the map. We need the from.
Yep.
From ID. And if that doesn't exist, let's just say we do this. It would be nice to know which one it is, right? It's not so much the user doesn't exist in this case. It's that from user. But the other thing we could do here, if we wanted to, well, let's just keep this for now and we can go back to it. There's all the error handling stuff we're going to have to deal with at some point. Let's just get Happy Path working right now. Okay, to ID. So there's our from, there's our to. At that point, we know how we're routing this message here, right?
Yep.
And we know that we need to do it now over the WebSocket. So this person's WebSocket. At the end of the day now, to.con.say write JSON, right? Which, given something like that. So we know then, given that message, we had a model already called this. This is what we wanted to use, right? And this was going to be the from user. So we got to construct a user. There's the ID.
Name.
There's a name. Okay. To. Nice. Name. And then the message. So
Okay.
now we're doing some data transformation. Somebody watching this might go, hey, why are we not just using this type, right? I mean, or why are we not just constructing it and doing conversions and stuff? If we keep these data models separate, this is going to give us more flexibility later as things are changing. But what's nice now is that this is the message we want to send over to that connection. There it is, right? Now, this could return an error. And here, we can just do that for now. And once that happens, we don't have to return anything else. But now, if this is the only thing that can happen, and we were just going to log this message anyway, there's two options here from a Go perspective.
Okay.
I like doing this. But some people might say, why don't you just put a return after that, since it's the last thing you're doing, and let the other side. I like being able to formulate that particular message, and then I know in the logs sort of what's happening.
Okay.
So I'm usually not a fan of just going, oh, it just so happens that the last function just returns a single error. Let's just put a return on this.
Mm-hmm.
I'd rather sort of read it this way. Now, we did break something with our handshake here, right? Because remember we did that with user here. So we were using this user. We'll have to look at this one in a second. We were using user here. So this is smelling to me now a little bit.
Yeah.
Now, when we did the handshake and we returned a user, was that even important to send the user back after the handshake? Really, I don't think this may not have been important to send back the user, because what we really need to do here, right, is more like the following. Once we send the welcome, see Copilot's sort of getting ahead of us already. Then it's going to be add that user,
Okay.
right? But I don't think this. Right, I think we can use the unexported type here because that's what we need. And then the add user, let's fix our add user API again. At this point, this should be what?
Yeah. Unexported.
Right? Unexported. We can use it.
And the same as remove user? Same for remove user?
Yeah, at some point. My guess is that's also going to have to be. I don't know enough yet, but I think it's a good guess, right? That's going to be. So what I tend to also like to do is put the exported stuff first. And then like the unexported stuff, sometimes I'll divide just so I can know what's exported and what isn't, right? So you've got that, you've got that. The handshake, we made that an exported API. In fact, that's like the first thing you have to do, right? So we put that there. And these are all unexported APIs. So let's continue on with this then. So we've got our handshake there. Okay. So the idea here is send message. Given a message, it's exported. The rest of these are unexported. I think that works. Oh, we didn't finish this. That's why. So now when we add the user, okay, we unmarshalled that user. We have the con. We know that this could only fail if
The user's already there. If we already have
that's right.
the UUID.
So we want to do this here, right?
Yep.
Because if that happens, what should we do? I think what we should do is close that connection, right? And then we can do a add user there. Now, what that tells me about add user, okay, what that tells me about add user is I don't think we need this error variable anymore. really don't. Because we're using it internally. You
Yeah.
can get away with a lot of things on the unexported side of your API that you can never get away with on the exported side.
Okay.
Because somebody else has to use the exported side. But you, on the unexported side, it's fairly for you. Now, obviously, you might have teammates that have to maintain it. You can't go crazy. But, like, I don't necessarily need this. I know I don't need this error variable anymore, at least not for that. So, because if this thing fails now, we knew what the one reason was, right? The user existed. So if we come back here now, we're going to immediately drop the other side. We're going to say, or whatever. We're not going to be telling them anything. That could be potentially bad. So another thing we could do is send them a message, right? Saying, right, add user, right, can't, or instead of welcome, denied, something, some
Yeah.
information, right? Already connected. Try to write that, then close it. Either way here even, we can just defer the close because we know we're going to want to close it.
Exactly.
That way, no matter what happens, defer the close. Try to write a message to them saying already connected. We'll log that information, at least. We're going to return from here an error. And then we drop them. Other than that, then you're here. So you can see here now on the add, we're using it internally after the handshake. And if they already exist, we'll say you're already connected. Blah, 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 blah. So that's kind of cool, right?
Makes sense. Yeah.
So now we come back to this, and they want to send a message, right? Error user not exist. I still think it would be nice to say, just for our purposes right now, and I think we can make this better over time. We don't have to know everything right now, just have to know enough. So error from, sort of error to, I'm going to send that message. At least we'll know which one it is.
Yeah.
And then what happens? We form this message, we write it to that connection, and we're done. So this sort of send message is helping with that routing that we talked about. So given a message, a from ID, a to ID, and what you want to do, we look for the person that wants to send it. They have to be registered in our system. They should be if they've gotten this far. You got to find the to. We can construct the information, and then we can send it out. That's kind of cool. And on the handshake side, we'll just sort of close that down quickly. Now, I have a red here on the remove user. So let's talk about the remove user. It would be nice if we can handle the remove user on this side. But to remove a user, we would have to know that the socket connection is down.
Yeah.
That's going to be the real problem. Now, my guess is that we won't know the socket connection is down unless we sort of try to write to it and it fails. All right? We would never necessarily know that it happened. So let's do something here for a second. Let's add another method called, we'll just keep it really low level here, okay?
Okay.
Send takes the message and it takes the connection. All right. In fact, I'm going to put the connection first. Now, ideally, Copilot is right. I want to do this, all right? And it doesn't even really need to be a method, but let's say 2. Now, technically, we can make this even a little cleaner. 2 is what? It's a connection,
yeah.
right?
Uh-huh. Okay.
Right. So why do I want to do this? Because if this thing failed, I mean, there's a good chance that if it fails, it's because that connection is
It's
down
not
or
there.
right. But I would put money on it. Oh, look at this. I wonder if we can use this anytime the connection is closed. That might be good. Because I was going to see if there was a way to... Oh no, this is some sort of... This is some closed message, as if it's sending you a message that it's closing, I think. I don't know if that's what we want there. It would be nice to be able to, at some point... Yeah. I don't know if we can assume that the close handler gets called when... See, closed messages as opposed to... We're going to have to test this.
Okay.
We're going to have to see when we drop a connection if that by some miracle gets called automagically, right?
Mm-hmm.
It would be a good sort of hack to sort of test, because I think it's going to be important. Because ideally what I want to know is, you know, there's no way to know if this connection is good or bad until sometimes my experience with the networking is until you try to read or write from that network connection, you don't necessarily know if it's working, right? And I was wondering if they had some sort of maybe context associated with this now. But remember, this is an old package. It's not anything new. But it would be super interesting to know if, when the client disconnects, if the close handler sort of gets called. And the reason I want to do this send is primarily where if this fails, let's just say that failed, and we're going to do a test very soon, then what we probably want to do is remove, right? I want to remove that user.
Yep.
I mean, you're done at that point.
Yeah,
There's no
they're not
reason
there.
to keep you in there, because if that failed, you're done. And what we could also do, once I've got your thing, just even force it closed, right? And then really drop it. So you've got opportunities there to then do that. Now, on the remove, we were returning an error, right? Maybe now it's just not important to return an error. It's just important to, again, we won't have any eyes on the fact that it existed, but we already know it exists because we wouldn't have gotten this far if it didn't, right?
Yep.
We just wouldn't have gotten this far. We already looked it up. So this might be good enough to where if we try to write, we could do the remove, we do the close. Now, if we're going to do a remove, let's put this back for a second. Okay. One could argue that we could do this, right? We can get back the connection. If it doesn't exist, just return. Okay, if it does exist, then so we could do something like this too, where, okay, we look it up. If it doesn't exist, then there's not much
Yeah, there's not much to
you
do
can do there. If it does exist, which is we expect it to, we can remove it. We can just force a sort of close on that. We're going bye-bye, that will affect the other side. And then this code essentially just does this. So that's one way to sort of detect that there are problems as soon as, but we don't want this hanging out forever either. So we're gonna need a way of also determining when something sort of goes bye-bye by itself. Now, I am interested in that other code. So what happened here? Variable mismatch. C is a WebSocket connection and context, and oh, we're not returning this anymore, right? Sometimes that happens to me. Okay. Handshake complete, but I'm not returning any user information now in the logs. But
Okay.
chat has a log, right? I mean, the way we wrote that. So if we wanted to do that here, I mean, we could write it in here, right? But this is going to be C, right? Or just move it. Because we're allowing logging in there, we could sort of do that. So we just do the handshake there, and we're good. Now, I don't necessarily like hiding the logging in here, but at the same time, we know we didn't need to send that user out. We're keeping it sort of internal to this system, which is fine. That's good. So I'm curious about one thing now. Let me sort of close this up. This was our little hack, remember?
Yep.
Where we read a message, and then we sent it, and then we sort of read it back. And that was dealing with this, right?
Yep.
I went through the whole handshake sort of thingamajig. So let's see something for a second. Set close handler. Given this function, all right, and let's do what Copilot is suggesting here. I don't know why people do that weird stuff on the chat. Does anyone have any sense on that? Info, oh, so it needs context. Needs a message. And then we could do, say, code. And we could do text. Okay, so what I'm going to do, because I'm just super curious, is rerun the code with this close handler in place, okay?
Okay.
And we're going to come in here, and we're going to connect. We're going to get the hello. I'm going to close it. It's going to complain, but it's okay. Okay, cool. So when that close happens, it would be nice to
Mm,
see that.
yeah.
Also, on the handshake side, right, because we're going to read it, but we're never going to send it. So that means that on the handshake side, right, we're going to be blocked here.
Mm-hmm.
That
Yeah.
should also sort of fail. So a bunch of things potentially should happen when we run this. All right, let's see. I don't know what's going to happen. But okay, let's look at our errors here. Error handling, handshake failed, the read message empty. That's beautiful, right? That's what we expected. That's this code right here. So I expected that read to fail,
Yep.
and it did. The rest completed. Hijack, hijack. Whatever. This is interesting. So we gotta figure what that is. This might be logs at the lower level
Mm,
of the handler.
okay.
So I need to understand that a little bit better. But if you notice, what we didn't get is, and I like this fail period. So this didn't ever get called, right? And I didn't think
okay.
so, because it made it sound like the other side would send a closing message type or something.
Okay.
Okay, so this is my point, is we can't sort of rely on that to know that this connection is sort of dropped. We know that the read failed, okay, but that doesn't work for us, does it?
No.
Now, in this particular case, we never added the user. Fine. But at some point when we're in this code, if that fails, then we're going to want to probably close remove, right?
Mhm, yeah.
So my guess is that this remove user for sure is going to become an exported. It just sucks if we have to do it at the, so that code that's in there, no. My guess is that code that you're seeing that we commented out is going to end up in here.
Okay.
It's going to end up in here. So anytime we call remove user, we'll also force the close on it, which I don't care if it fails, and then we delete it out of the system. And right now, if we go to send and it fails, we'll just remove it. We'll write that message. Now, again, mux21 web respond error respond right connection has been, I don't know what, I mean, we're going to have to look at that stuff at some point. Oh, this logger got in here. So our web app returned this too. These are things that maybe we want to ignore at some point once we get a better handle on it.
Mm-hmm. Yeah.
Okay. So this code here, I think, is moving into our chat at some point. So what do we got so far? Okay. We've got our handshake here. That's exported. Performs our WebSocket, right? Performs the connection handshake protocol. Cool, right? We know that works. However, if we go to add you as a user and that fails, you're already there, we're just going to shut you down.
Yeah.
Okay. Else you're going to get a welcome, and we'll say handshake is complete. Now, I don't know if I like this log here, to be honest with you. I know we have a logger in here, but, and I'm going to leave it, but it smells a little bit to me. Okay, then on the message side, we're going to send a message from to message.
Yep.
We make sure that the from and to are in our map.
Yep.
If they are, we formulate the message that we're going to be sending,
Mm-hmm.
and we send it. If the send, for whatever reason, fails, we take them out of the system. Okay. The add user, if the users already exist, we'll fail that. We saw that. If not, and then not, we add them in a connection. Name icon. Name icon. Yeah. Don't need any JSON tags on this one. This is an internal sort of type. Does this one need JSON tags though? Because, yeah, because we're sending it out the door there, right?
Yep.
However, this one doesn't need JSON tags because this is input. And the operator shouldn't necessarily be using that for what's coming in. It should have to marshal into that.
Okay.
So we'll see that. So these are the only things that need coming in and out. But the funny thing is that the other side, yeah, I think this one's fine. Let's stick with this right now. Okay. So we now have the ability, after a handshake of adding the user, to be able to at least route it all the way through. I
Yeah.
feel pretty good about that. Whew. So we're now kind of in this code here. And I feel like this code should also be abstracted in our chat package.
I agree.
Right? I mean, once you do the handshake, I would almost want something like, yeah, web no response. I would almost want something like they chat. I almost like that word listen,
Listen,
for lack
yeah.
of a better.
I like listen.
Now, I like listen. Now, I don't think it needs to return an error. The question, though, is we've already added the user to the system. Yes, but we're going to need this because we're going to be trying to just read on this. We're waiting for messages to come in, right?
Yeah.
So we're listening for messages to come in.
Mm-hmm.
I kind of like that. This send message might end up being unexported too, by the way. I like the idea of listen. I don't think it needs to return an error because at that point we're in a communication,
Mm-hmm.
and once it returns, it should just be done. I think we'll find out more in a second. All right, but listen now, right? It performs. Listen. Waits for messages and waits for messages from users. I mean, that's really sort of what it's doing, right?
Yeah.
So this gets fun because there's a couple things that I know we need to do. The handshake, okay, we need this code here for sure. This code sends the ping every second to make sure that that client is sort of still alive. The other thing we can do, though, even though I did the ping on this side, we might want to read this, is, oh, I don't want this anymore, right? Is that maybe what we should be doing is not the ping, but the Pong side of things. So why is this having a hard time with the, yeah. So I'm wondering if we shouldn't be doing ping here. We should be doing Pong, right? Where the client, we have to read who's responsible for doing ping and who's responsible for doing
Okay, yeah.
sort of Pong here. It's nice if we do ping because we're trying to make sure that the client is there. And then if the client doesn't Pong, then we drop them, right? So let's keep this ping telling clients have to do the Pong. Hey, you still there? Yes.
Okay.
Now, for me, this code should probably be handled in the handshake side of things. And I think this can be an orphan Go routine at the end of the day. I don't care if this Go routine gets sort of its head chopped off. So let me do this for a second. So what if I just call this the ping?
Okay.
I don't know yet what's happening here. Let me undo this. And I just need to start a Go routine that is in an endless loop. And it has to be on that connection, doesn't it? Can't just be, that's a bummer. But we have socket connections, don't we? So what if we did this? Every time the ticker goes off, what do we know? We want to perform this sort of ping.
Yeah.
But I want to perform it on all the sockets that we currently have.
Oh. Okay.
Right? So I'm going to write bad code here, and then we're going to write better code here. So the chat has the read write. Why did I call this WG for wait group? It should have been called mutex. That was silly me. Didn't we use the mutex for mutex, not wait group? Just caught that now. Okay. So let me just do a read lock. Now, one way we can handle this is that our map is a set of these connections, right? These are pointers to the connections in this. So one way to do this is to bring back a copy of this map, and then we can safely, concurrently, sort of run through it. There won't be a problem. And to me, that's always the safest way to do this situation. If we iterate over the map and we hold that read lock for a long time, it kind of gets ugly. But if we just make it's be faster potentially to make a copy of it. I mean, even if you had 5,000 connections, right? And so this is something that we can test later, copy versus just holding the read lock and iterating over this. But let's say that we were going to do a copy of this, okay? So connections and have that return a map of connection, right?
Okay.
Now, I can't have it do this because that's not a copy. That adds no value to our life. So what we have to do, and that wasn't bad, we have to do this make, and then what we have to do is range over that, do exactly what that's doing.
Copilot helping out.
Yeah. and then return M. So at this point, we're just making a copy of it. And we'd have to start at some point gauge whether the copy is going to be nice, because all this sort of goes away here. I just say connections. See, there's no read lock, there's no read unlock. It just give me the connections.
Yep.
And now in this code here, I know it's safe for me to iterate over that map because it's my own copy of it.
Exactly.
All right.
Yeah.
It's not that things couldn't change, but at least it's our copy of it. And then with this now, we can say range over M. All right. And I would almost not even care if it failed. It's just pinging. Now, we could do this though, okay? If that fails, then maybe.
Oh, remove.
Move user, right?
Yeah.
And remove user takes a user ID. And our map would be then, okay. Yeah. That's kind of cool. So this gives us another sort of opportunity to, I did something wrong here too. So that's my 4. That's my, what are we missing here? If error, oh, sorry, better.
Oh.
And the V is actually the connection, right? Connection. C.con. C.con. Oh, this is just C. Nope, this is, oh, here's my problem. C,
Okay.
and then
it's
I used C here. So if I just stick to value, that will be fine.
there it is.
So
Okay.
now it's not happy about something else. So let's see, should use a range instead of a, oh, yeah, you're right. I don't need the select because it's just one. This is where the linter's sort of nice, right? Let's see here. I should be able to do that. So this is the only thing that we care about, this ticker. And then when it goes off, we can make a copy of the connections. We can range over them. One could argue too that, just do that, right? And then we try to send the ping, and then if any ping fails, we could just assume that that user's bad or
it's
gone.
not working.
And we just get rid of them.
So we can. Yeah.
And the good thing too is, and the mistake you would make is, we didn't make this copy. We might have already been in a read lock, and then you want to call remove, and now you're trying to get into a regular lock, and bad things happen because you're already in a lock. So what's also nice about not having any of that stuff here and separating it is, once we get this map, we're out of the read lock, and then if we need to get into a write lock here, we can. And that write lock is happening on the original map, not on our copy, and there's no issues there either.
Got it. Okay.
So, you know, when we're dealing with this sort of concurrency code, if we could operate on our own copy of the data, oh my God, dude, it just
much better.
cleans things up. So here's another opportunity for us. In fact, this is really beautiful here, because if we send a ping every second, every second might be too much. Maybe we do this every like 10 seconds. I don't know what the protocol is. We have to read it again. But what this would mean is every 10 seconds now, we're constantly cleaning up our map for connections that are not,
Yeah, they're not doing.
they're not
anything.
there. And that solves like a really big sort of problem,
Yep.
you know? So it's a really big problem for us. To the point even where, even that other code we wrote, I don't remember where it is, where this one's fine because it never got into the map, right? But one could almost argue here on the send. If the send fails here, I mean, I think that's good to do there. But we know the ping is gonna eventually run too.
The ping will catch it too.
And it's
Yeah.
gonna like clean it up, right? And so almost for me now, I think that we could rely and keep this simple on the ping to sort of do it all. Okay, that failed, that's fine. But then when we get on the ping side, if that fails, then fine, right? Like we have a single place. So
Yeah.
if remove's not working, we have one place to go right now. And if
Yeah.
we can keep it there, that's going to be really, really, really nice. Yeah, it might have been efficient to do that, but eventually it's going away anyway, right? We won't get a copy of it and all that.
It won't be there longer than 10 seconds.
No. And this is going to create a go routine, but now we're going to be one go routine for all the connections here, right? So what's nice about ping is we could start the ping process here,
Okay.
right? Like it even happens at the time that we do the construction,
Exactly.
right?
Yeah.
And now if there are no connections, it won't do anything anyway, right? And we'll just get back an empty map. So that's really nice. So at the start of the beginning, we'll already start this sort of ping process. Now, what we could do, so we're removing it in a copy. No, Joseph, the remove happens on the original map. See right here on line 163. Happens on the original map. What we're doing is operating on a copy here, so we don't have any like side effects on the concurrency stuff. So we're reading a copy, removing on the original there. Now, what will be nice here, all right, maybe, especially for this initial debugging, is if I do an info here. Now, from a context perspective, we're not on a request or anything, so we could do a background here, and we can do ping, right? We could say status started, and then when we're done with this, you can't do a defer because we're in a loop here, right?
Yeah.
Completed. And then what we can do is we'd have information here, right? User, and that's K, right? K, V is a connection. So we could use v.name, and we have a v.id, right?
We should, yeah.
So that's kind of cool, right? We could just sort of log to see who we're pinging.
Mm-hmm.
And then if there's any sort of failure there, again, for our debugging purposes here, this can be remove user, and in this particular case, it's connection, right? But I could just be, sometimes I like just using V, man. It's just like, this is the value out of the map,
yeah.
and it can be sort of small, right? V there. So now we know we're removing that user from there, right? So a little logging goes a long way. And even here, we could just say, in this case, though, it doesn't exist, right? So I like the idea of a status. Does not exist, right? So we've got some information there as well in terms of that. And then, you know, we could do the same thing with the add user when the time comes here. That's adding it to the map, right?
Mm-hmm.
So add user, and in our case, it's our user here, user. Now, user dot, in this case, it's name and ID because of that model.
Mm-hmm.
Right?
Yeah.
We sort of have that. And, we called this a connection, so that's fine. So we have that. And again, because we're already doing logging in this thing, even though we're returning the error there. See, when I'm returning an error, I don't feel like we need to log it because the other side's going to log the error,
the other side's gonna
right?
get it.
And it will log it with the context. But for the things that we're not returning, it might be nice for us right now, like we just return an error, no error there, to log that. And now in the ping, we've got started, we've got completed, and we can see where we're, and then if we do call remove, we'll see within the scope of the ping, the sort of remove user, right? So that's kind of cool. And that ping gets started auto-magically at construction. And then, right, again, we already have a message because we made that the local variable. So we do M there. And now, if that fails, that's fine. The ping's going to come in and sort of take care of that. Okay. I really like where we are right now with this. You can see how it's shaping up.
Yeah.
Now, to be fair, somebody might look at this and say, Bill, if you had started the app layer already, then you would have kind of known the way this was going to shape up. And I can't necessarily disagree. I mean, this is what our app layer now is, right?
Mm-hmm.
We upgrade it, you perform the handshake, and then you're going to go into some sort of listen mode. But you have to see the process that we're going through in terms of refactoring this and trying to get to a point of engineering. Now, we've written way too much code for my taste so far that I haven't tested. But this happens at times, I'm still a little queasy on this right here. But again, everything here is happening sort of internally, right? I mean, even to the point now where I can argue that this send message is no longer going to be an exported, it's no longer going to be an exported. I'm going to reorganize all these unexported things. I like to keep things in sort of the order that we need them. But when I think about this now being unexported, right?
Yeah.
Even this probably doesn't have to be an exported thing anymore. And remember what this was. This was the sort of inbound request, right?
Yeah.
That was the outbound request. And I keep using this word inbound, so I'm going to keep using it. This is the inbound message, right? And this was the outbound message. So sometimes I can't do that. I like the word message. Oops. Sometimes I do that too. So I don't know if I'm going to say in message. And I had this earlier, right? I had this earlier.
Yeah.
And so on the send message, I want what was the inbound message.
Mm-hmm.
And then this is the
Out.
out message. And then what's nice is everything here is unexported. This is making me feel so much better, right? And if we read a story from top to bottom, the first thing that we use is this connection type.
Yeah.
Then we're going to receive an inbound message. Now that tells me that we can do it this way too. I was working with some JavaScript front-end developers recently, and they say they don't like this. They like the camel case because they have to read this in JavaScript, and they just hate having variables with underscores.
Yeah.
That's kind of why I stopped using underscores for this stuff, because that ends up becoming sort of JavaScript variables.
Mm-hmm.
So, if we're using Go idioms, that's sort of the better way to do it, right? But now everything's unexported here, which makes sense because, again, all this is going to look like is this. I mean, how clean is that? Handshake. If the handshake doesn't fail, then listen. And we need that so we can fail appropriately. And then our models are basically inbound. We know we need a ID string. Outbound, we're going to know the user information. And again, I like to read things from top to bottom. So normally, I would put this here because I read that, I'm like, what's a user? I haven't seen a user yet. Oh,
Yeah,
no,
the
I have
user's
seen
there.
it, right? So like a story in a play,
Yeah.
right? You introduce your actors.
Yep.
So why am I talking about user if I haven't even told you what like, it just helps with readability. So that's kind of nice there. Now, I know this is going to be unexported because this listen is going to end up having to use this. So let's go back and look at a little bit more code. I think if I'm just going to steal all this, even though I don't need it. This is where connect is at this point.
Yep.
Upgrade, handshake, listen. I don't care what happens there.
Yep.
Not going to return another error. So no web response. And then here, we got to think about this. Now, this has to be a blocking call. Okay? We're going to block this listen thing here. So it's going to be a blocking call for sure. And it's going to have to be in this loop. We're going to have to figure out how to cancel it. But I don't think we need, let me just do this for now. Let me just think about this. We want this in an endless loop. However, if the read message fails,
Yep.
okay, then I think what we want to do do something like that and just return. That's fine. We got to think about shutdown though.
Yeah, because there has to be a way to.
Okay, well, let's get there in a second. Then this is the message, right? So we block on read. If it fails, listen's done. We're dropping out. Again, that ping will eventually drop us out too. We'll test that. But if this doesn't fail, now we've got this JSON string, right? That's the in message. JSON.unmarshal the message into the address of this. If that fails, yeah, then I would do that. And then if that doesn't fail, oh, I can't use message. I used it there. In message. And if that fails, I don't know if we want to die if that fails. Because we're fine. We just couldn't send the message to this person. So I think what we want to do here,
Is check
if it fails, I think I just want to log it and log it.
Oh, okay, because some messages already in it.
And then we go back to the top of the loop and read again,
Yeah.
right?
Yeah. Okay.
And okay. And this has to stay until that sort of fails, and then that will return. Dude, I think that's freaking it. I mean, there's a bunch of error handling and stuff we haven't done yet, and socket connections dropping and shit. But I think from a happy path perspective, this gets super interesting. So we've got an API with essentially two exported methods here. Handshake, which we know works,
And listen.
and then listen, that's reading messages. And then if we do that right, then it will send the message back out. Send message sends one of these out messages. out, and then that can be displayed. We can get a copy of the connections. I hope Joseph understood what we said there. And then this ping is really nice. This is an orphan go routine, but I don't really care because it doesn't affect anything. It just will just keep sort of running. When we shut down the system, we can just shut it down. It's fine. We've got our add users. Everything's in memory. So that we've got the remove. We've got a read message, which is used as part of the handshake, isn't it?
Yeah, handshake.
So let me think about this read message. This is the same. Okay, no. Well, this is just reading a message in general. Right? And that's the same thing we're using. We better be using that here. See, I don't know if I want to use that. What if we use our read message here? Right? And then this returns. See, that was going to be a mistake. This way we can cancel that if we wanted to.
Okay.
Now, we've got a problem though. This just made me realize we have a problem. We can't be using this context if there's a timeout associated with it. Right? We can't be doing that. That was going to cause a problem.
It just needs to stay listening.
Now, but no, think about it again though. I don't think we didn't set a timeout on this context here. We should have probably done one here, but we really didn't. And this is the context related to the request. So I think we're going to be okay. We're just going to keep this sort of in the back of our head there, that we've got that context. Because if the whole thing drops, then this context will disconnect, which is what we want.
Okay.
And then this read message that we created to allow for respecting the context will work. Okay. So actually, that is the context we want. The mistake we made is not using our context-aware sort of read to do that. We're not worrying about that on the send side, but on the read side, I think we needed that. So that was a good code review for that. So I think we now have a server, and everything's on connect, which is super interesting, right? So I think we have a server now that we can try out. We just have to go and hack a little bit more.
Okay.
Got to hack on this a little bit. So this code did the handshake up to this point, right?
Yeah.
Okay. We're going to want to run 2 clients here. But we can do that in the terminal in multiple windows. The thing now is we've established a socket connection. So it would be kind of cool if we could do funct print line or funct print enter message, enter what if we told it to do it this way for now? ID message, right? Okay, I want to read standard in. I never remember the best way to read standard in. I think, all right, let's do it quick. Let's do a chat GPT. I have chat GPT and I never use it. Let's see here. Let's try this. I never use this. Ask Copilot. Golang read standard in for keyboard. Let's see how that works. See, this is nice, bro. What's wrong with that? I find it funny they gave me some WebSocket stuff. What are they doing? They just printed out this.
They're giving you the code with the
Oh
changes.
my God, dude. I've never tried that before. What? That's pretty wild. So the buff.io, read until you see an enter key. Oh, that's it. That's exactly what I want. Dude, that was badass. Oh my God, bro. That's faster than me trying to Google this shit. Oh my God, dude. I was like, thank you, Copilot. Okay, so we just kept it simple and we said ID : message right now. And yeah, just to keep it simple. Then I could do strings dot split the input and that.
Okay.
This gives me the different parts, right? And if the length of parts doesn't equal 2, we'll just kill that thing, okay? And now, yeah, that's not a bad idea. I could do that. I don't know what else we want to do here. It's not a bad idea. Gets us going. All right, then we're just hacking here. So, not a bad idea. Now what? We need to send this message. Oh, we need the message type. So what was our message type actually? The inbound message is this, right?
Yep.
Okay. So I'm just going to put that down here for a minute. What we really need is the in message.
Mm-hmm.
And the from ID. Okay, so let's come up with a unique UUID for you, right? Actually, we're going to make this even simpler for us. Copy. Just a hack, okay? So user1, constant user1 equals this. Generate a new one. User2 equals this. Let's just do that for now, okay?
Okay.
So we got user1 and user2. And what we'll do is we'll expect the user1 or user2, right? So we'll type in there 1 or 2.
Okay.
And we'll
Got
know
it.
which one it is, okay?
Got it. Okay.
For now. Or we can even be somewhat fancier. Our little hack session here.
And then instead of user1, just user.
Yeah,
Or
so
users.
this would be either 0 or 1 right now, okay? And then the from ID will be based on this. So I don't want to do it that way. I just want to know if it's 0 or 1, right? So we could just do a real hack here. Look, str convert dot a to I ID, and then let's just say this is the ID string. Here's the ID. Could be an error. I'm going to be really nasty now. Don't ever do that at home. Yeah, we better log that in case that fails. If the day that I don't do that is the day that it always fails. So, invalid ID, that's fine. ID string.
And what is A to I doing?
That's converting alphanumeric to int,
Oh, okay.
is what I guess it means. So, from, okay, so again, I'm moving really fast because of the time, and I just want to use this one client. So if we ideally we should use a flag to say who you are and all that sort of groovy stuff. But because I'm running out of time, let's do this. Okay, we need a from and we need a to, right?
Yep.
And I need one of those right there. So I could just, again, hack this right now and say from this is a total hack. We got to clean this up. But I'm now rushing because of time. So we can right now say from 1 to, but if ID is 1, we'll reverse it.
Okay. Yeah.
Again, just hacking here. All right. So if the ID is 0, we keep this. If it's 1, we keep this, because now we can say from message is a UUID. That is not a UUID. So we could do this to make it better for ourselves. UUID.must parse, so we don't have to worry about error handling on this little hacky sack of ours. We're going to clean this client up tremendously. All right. Nice, 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 nice. So from to ID is our to, and your message is going to be that. Now this doesn't like, oh, do we already had a message? Yeah, right there, read message. So, and I don't want to fight that right now. Now that you have the end message, this has to be in a loop and everything too, bro. We're running out of time to do this right. Well, let's just hack this right now. So we need one of these, right? Yeah, but both sides are gonna send it at the same time. Oh no, only if we hit enter. So, write a message, write the data. So now we need, didn't we just, oh, we just sent the string, but we need to send JSON, right?
Mm-hmm.
That's what we need to do right there. Oh, I hate when I have to rush.
Speed coding right now.
Okay, that's fine. Really, that's supposed to be %W. All right. Are you complaining because I already have data? No new variables on the left side of that. So, God, this is horrific. No, dude, we're gonna have to clean this up. So, that would write the message, right? But I still need the little go routine that we did here to sort of listen. So let's do one more little hacky sack here. This was the marshalling side, right? That's this. Again, we're gonna create an orphan here. None of this is clean. We're going to create an orphan here. We've got to obviously clean this up to do that. That's our socket, right? Now, this read message, though, will have to be this.
Okay.
I'm just going to do a print f here. Whatever. This is gonna be just a printf. I don't care. But this is gonna be an out message. nasty stuff
Yep.
we've got to deal with later.
Yep.
It's okay. It's just, this is what happens when you're just hacking along. That's an out message. And then we can just bump dot print line. So if it reads that, and then it should just dump it out. It's all ugly as sin, bro, but make it even worse. Just do that.
Oh, goodness.
No, man, that is what it is. Percent V. All right. Again, we're orphaning this thing out. Maybe it's okay just because it's reading. And then this is even uglier because now I just put this in a loop and I don't know. So we want a user, which is either 1 or 2.
Yep.
No, 0, 1.
0, 1, 0.
And then a message. So we'll read that. We'll capture it on the enter. We'll split. We'll determine who's who. And we'll write that message out. And then, yeah, there's no way to die unless, how about we do this? Yeah. If we just hit enter, then it will kill the loop. We'll just return. All right.
Okay.
3 minutes to see if this little hacky program works. And then on Thursday, we're going to have to clean all this up.
Yeah.
Yeah, that's right. Okay.
Severely.
All right. I'm going to do that. Okay. No. Change directory. Ardan. Okay. I didn't create a make for any of this client stuff, so we should sort of do that. Oh, we had client hack, right?
Yep. Chat hack.
Okay. Okay. Oh, look at this.
Oh.
So we ain't gonna get this working because we had an entry to a nil map on line chat 175. Where's everybody that's watching that didn't see that? And they're right, because I forgot
To put it there.
to do the make. That's what I want to do here. Just, all right. That would help. All right. Feeling better about myself now. No, don't get too excited yet, bro. We got a lot of. Don't get excited yet. Now, if I say 0, oh, no, this isn't going to work because we didn't specify. Let this die. We got to do one more thing here, if this is going to work. On the handshake, you have to say who you are, or this doesn't work, right?
Yeah.
So, you see, we're going to have to pass in the arguments, bro. So, we're going to have to do something like this. Yeah, I know, git push. Hold on a second. OS args sub 1. If r equals 0, then we're going to create a variable called var ID UUID. So if it equals 0, then from 0, Again, I am hacking horribly here. Case 0, do this. Case 1, do that. So that's your ID in UUID sort of form here. Then what we can do, say that's your ID. Okay. And then what we can do here is basically the opposite is what we really want. Oh no, we'll say 0, 1, that's fine. It would be nice to do the opposite though, which was sort of args sub 1, right? So let's just clean this up to just say message, and we'll hard code the other thing here.
Okay.
So I don't need parts. I just need input. Let me get rid of all of that. Oh, that's Trump. Okay, so this is what we know. Let's take that switch again. We're going to go over, but I just want to see this sort of work. Okay, if ID was 0, if we passed in 0, then from is that and to is that, right?
Mm-hmm. The other way is the opposite.
Yeah. And if it's the other one, it's the opposite. And that's just a good sort of hack. We don't even have to pass that in. And then this is going to be your input. So now we just have to, when we call hack, okay, hack 0, hack 1, right? And what we'll do is when it first comes in, we'll go from .print line with the ID. So that should be enough of a hack for us to where when we read the message, yeah. All right, let's try this. Hack 0. Okay, there's you there. Hack 1. Let's see what happens, man. Hi there. Dude, it printed it out.
Hi there.
That's pretty good. So let's do the following in our little hack program before we sort of finish here. And then we'll figure out what we're going to clean up tomorrow. If we just do that, we can see here that listen, read, empty, request complete, handshake. Here's your hack 0. Let's see. Okay, so
We're getting errors.
we might be getting errors because there's the remove user on the ping. So because it hadn't been removed yet,
Okay.
it wouldn't let us connect. So that's a bug we're going to have to fix on sort of Thursday, because the ping alone isn't enough. We are going to have to add back that remove when these sorts of things
Yeah.
fail. We're going to have to be smarter.
Yep.
Okay, so hi there, Kevin.
Nice.
Hi there, Bill. Okay,
Cool.
it's working, right?
Cool.
This is ugly as sin. We got to clean all that up. This controls C on both of these, right? You see where it says empty message on the listen read?
Yep.
We need to be removing that before
This
sort
is-
of the ping. Okay, let's do the following. We have the basics working right now.
Yeah.
This needs a full code review on Thursday when we get there. And nobody should ever look at that client code because that is ugly as sin. But let's go ahead and do this. Git add, git commit. Basic chat working, right? Oh, we're gonna have to push this one more time though. Let's go back to this and while we finish this up. Chat app, domain, chat app. Okay, so what do we say now? We have basic chat working. Need work on socket drops, right?
Yeah.
Don't judge on the client right now. And then I think we gotta sort of figure out next steps. So we definitely want to clean that client code up for sure. We can even make this work in JavaScript. But we saw other things that we could do as well, like the multicast and all the other sort of stuff that we're doing. But first thing we're going to do essentially, start with full sort of code review and client cleanup. Okay, so
Nice.
that's pretty good. But look how beautiful this thing looks at right now, man. I love that. I love the way that looks.
Much better than the first, how we started.
Now, what's even more interesting to me, again, we're way over, but I'm going to do it anyway. This feels low level, doesn't it?
Upgrade, yeah.
Now, we could move the upgrade in here, but I just realized that probably having the defer code there is fine, and that's transport. So I'm going to leave it. My first thought was we could hide it in the handshake, but I don't know if that's fair to do. But beyond that, this is super, super clean for where we are. We have it really working. All right, let me push up those final to-dos, git commit, and final to-do. All right, so we're pushing that. I don't know about you, but I'm pretty happy with where we got. I was nervous for a second, bro. I was like, oh man, I'm lost here. I don't know if we're gonna get this working. I love when it works right out of the box though.
That's perfect.
Right? It's like we read all this code and the damn thing works. I just forgot to initialize the map.
That was it.
Damn. But look, this is still some level of programming. I'd say there's some really good initial engineering here, but like this isn't ready to go put into production.
No.
No, but it's all those socket drops and those types of things that we're going to have to work on probably on Thursday to really tighten the screws. So we're going to have to build some clients that can talk like this really fast and then kill, see what happens. Kill, see what happens. And really get that tight. And then once we get that tight, we can sort of add on to it. But I think so far it's pretty,
it's nice.
pretty
It's
cool.
cool. It's cool to see it work.
Yeah, it's good. But like I said, we definitely need another day of some real cleanup before we do anything else. But
Sure.
anyway, I hope for those of you that were hanging out today, watching me hack a little bit, I hope you had fun there. The code is there. We'll do more same time on Thursday. Other than that, I think it's time to sort of sign off. I'm going to hit the 4 button here. There we are. And we're done.
We're done.